Surrounded by barren desert covering 96% of its land area, while a population confined along the Nile corridor has increased more than fourfold in just under 70 years, Egypt has been compelled to undertake one of the most ambitious agricultural megaprojects of the 21st century, transforming nearly 1 million hectares of the Sahara into a second Nile Delta. This is not merely a battle against the desert, but also an effort to reshape a new agricultural model for the future. Beginning with massive water treatment plants along the Mediterranean coast, billions of liters of water are pumped through modern canal and pipeline networks, then distributed deep into the desert to transform barren sands into vast green oases. So how are Egyptian farmers and engineers creating a new delta capable of producing millions of tons of food in one of the harshest deserts on Earth? Join Agriculture Insight as we explore the journey behind this remarkable achievement. Nourished by the Nile for more than 5,000 years, Egypt, the cradle of one of the world's greatest agricultural civilizations, is gradually reaching the limits of its own survival. The country's greatest paradox is that it possesses nearly 1 million square kilometers of territory, roughly equivalent to the combined area of France and Germany, yet less than 4% of that land is actually suitable for cultivation. However, the problem is not simply the lack of farmland. The problem is that it is almost impossible to expand. While the population of this Muslim-majority nation continues to grow by around 1 million people each year, the amount of arable land has remained virtually unchanged, an inevitable limitation. Worse still, about 25,000 hectares of agricultural land disappear every year due to urbanization. As a result, nearly 60% of Egypt's food demand depends on external supplies, making the country one of the world's largest wheat importers. Not only is Egypt constrained by its harsh deserts, but it also faces a critical vulnerability. The entire nation depends almost entirely on a single river. Approximately 97% of Egypt's freshwater supply comes from the Nile, a river stretching more than 600 kilometers across 11 countries. Yet most of its flow originates from the Ethiopian highlands, where the Grand Ethiopian Renaissance Dam has raised concerns about the future of Egypt's water supply. This means that the fate of more than 110 million people depends on a river whose flow is not entirely under their control. While many see only hot, barren sand, Egypt sees a vast reserve of untapped land. If water can be delivered there, these areas could become a strategic space for absorbing population pressure, expanding food production, and strengthening national security. As a result, Egypt began constructing an unprecedented irrigation system, collecting, treating, and redistributing million cubic meters of water every day to transform nearly 1 million hectares of the Sahara into a new food-producing region for the 21st century. However, this is not the first time Egypt has attempted to turn the desert into farmland. Decades ago, the country placed enormous hopes on Toshka, a project celebrated as a miracle in the desert, yet its actual results fell far short of initial expectations. So what makes Egypt believe that this time will be different? And to understand how Egypt could create a second Nile Delta in the heart of the Sahara, we must begin with what seems like an impossible challenge: transporting millions of cubic meters of water across the desert. In 2021, the New Delta project was officially launched. More than 12,000 workers and hundreds of heavy machines operated almost around the clock, transforming the area into a massive construction site in the middle of a sea of sand. The first step was stabilizing the terrain, as building on constantly shifting sand presents a major challenge. Across a landscape where sand continuously moves under the influence of wind and temperature, hundreds of bulldozers worked relentlessly to level the ground, remove large sand dunes, and reshape the entire desert surface. Once the site had been prepared, canal excavation began. The canal was designed to be about 45 meters wide and 7 meters deep, capable of transporting enormous volumes of water using gravity alone. At the same time, the accuracy of the entire route was strictly controlled. The longitudinal slope was adjusted with an error margin of only about 2.5 centimeters per 30 meters, a level of precision that is almost unimaginable for a project stretching hundreds of kilometers. Amid temperatures exceeding 50 degrees Celsius, the entire construction site operated like a giant machine, constantly moving across an endless sea of sand. Excavating the canal was only half the battle. The bigger challenge was moving billions of liters of water across more than 100 kilometers of desert while minimizing losses along the way. As a result, preventing water loss became one of the most important objectives of the entire project. After the canal bed was stabilized, a layer of fine sand, approximately 5 centimeters thick, was evenly spread to create a cushioning surface before 10 to 12 centimeter thick concrete slabs were poured in standardized sections. Between the concrete slabs, expansion joints were sealed with hot bitumen to prevent leakage and allow the structure to expand and contract under the desert's extreme temperature fluctuations, where temperatures can range from around 10 degrees Celsius at night to over 50 degrees Celsius during the day. Upon completion, more than 124 kilometers of canal had been reinforced and waterproofed, creating one of the largest water conveyance systems in North Africa. Once the canal had been fully reinforced and waterproofed, the next step was the art of flow control. Along the canal route, intermediate regulating reservoirs covering approximately 2 hectares each were constructed to absorb flow fluctuations and maintain a stable water supply. But a giant canal alone could not support nearly 1 million hectares of farmland. Water still had to be delivered with precision to fields scattered across the desert. From the main canal, pipelines ranging from 1.5 to 3 meters in diameter are installed to deliver water to new agricultural areas in the desert. Most of the system is buried underground to minimize evaporation losses, while high-capacity pumping stations and automated control systems continuously regulate the flow, ensuring a stable water supply throughout the region. But what makes the new delta fundamentally different from Toshka and many desert reclamation projects before it is not the scale of the project. It is the water behind it. Most of the water comes from the agricultural drainage system in the Nile Delta, where it is collected and treated at massive facilities such as Al Hammam before being pumped back into the desert. When the first control gates were opened, water began flowing through the newly completed network of canals and pipelines. Every day, more than 7.5 million cubic meters of water move through this system, making the new delta one of the largest water redistribution networks ever built in North Africa. From this point forward, Egypt is not simply bringing water into the desert, it is recycling its entire irrigation system to create a new food production engine for the 21st century. As the first flows of water began moving through the new network of canals and pipelines, vast green oases gradually emerged across the heart of the Sahara. Spanning nearly 924,000 hectares of newly cultivated land, these remote desert regions are becoming one of the agricultural hubs contributing more than 15 million tons of agricultural products each year. For many Egyptian farmers, this is the first time they have watched the desert give way to green fields. One of the new delta's most important objectives is reducing Egypt's dependence on imported food. Wheat, the country's staple crop, sits at the center of that strategy. Egypt still imports around 10 to 12 million tons of wheat annually, equivalent to nearly 60% of domestic consumption. As harvest season arrives, wheat fields stretching for dozens of kilometers begin turning their characteristic golden color. High-capacity combine harvesters operate continuously to complete harvesting as quickly as possible, minimizing losses under the desert's extreme temperatures. Thanks to the vast new agricultural land in the Sahara, the new delta has the potential to add approximately 1 to 2 million tons of wheat production per year, about 4 times the wheat output that Toshka once achieved. But Egypt's history includes numerous desert projects that failed because the soil quickly became salinized. This raises a question even more important than production. Can the new delta endure for decades, or is it merely a short-term success? To avoid repeating the failures of the past, New Delta was designed not only to bring water into the desert, but also to control salt accumulation through drainage systems and continuous soil monitoring. In the long run, the project's success will be determined not by how much water is pumped in, but by its ability to preserve soil fertility for decades to come. Egypt is not only trying to grow more food, it is also trying to reduce billions of dollars in agricultural imports. With more than 3,000 hours of sunshine each year, the hot, dry climate of northern Egypt provides ideal conditions for sunflower cultivation. Low humidity helps reduce pests and diseases, while abundant sunlight increases the oil content of the seeds. Beyond supporting domestic cooking oil production, sunflowers also help Egypt reduce its dependence on imported vegetable oils. Every year, the country spends more than $1.5 billion importing edible oils and oilseeds to meet the needs of its population of over 110 million people. With average yields of around 2 to 3 tons of seeds per hectare, and oil content exceeding 40%, each hectare of sunflowers can produce nearly 1 ton of vegetable oil, significantly higher than many traditional crops under arid conditions. This makes sunflowers an ideal choice for the dry lands of the Sahara, where every cubic meter of water must generate the highest possible economic value. While wheat sustains the population at home, Egypt's legendary cotton is grown to compete in some of the world's most premium textile markets. In an industry dominated by massive producers such as China, India, and the United States, Egyptian cotton accounts for less than 1% of global production. What makes this cotton so special is something that is almost impossible to see with the naked eye. Extra-long staple cotton varieties possess fibers that are significantly longer and stronger than those of conventional commercial cotton, allowing the production of premium fabrics renowned worldwide for their softness and durability. But that quality also comes with strict requirements. To preserve the fiber structure, much of this premium cotton must still be harvested carefully to minimize damage during production. Its exceptional value has also made premium cotton one of the most counterfeited products in the world. In 2016, Walmart, Target, and Bed Bath & Beyond were even involved in a controversy after selling products labeled 100% Egyptian cotton that were later found to contain different types of cotton. These controversies only further highlight the unique value of the Egyptian cotton brand. With cotton exports generating more than $500 million annually, and the textile industry contributing nearly $4 billion in revenue, Egyptian cotton remains one of the most important pillars of the country's economy. Beyond crop cultivation, livestock farms, food processing facilities, and logistics hubs have also been developed, while crops such as corn, sugar beets, potatoes, and olives are helping transform the desert into a diversified agricultural hub. The true significance of the new delta may extend far beyond the borders of Egypt. As the global population continues to grow and climate change places increasing pressure on water resources and agricultural land, more and more countries are facing the same urgent question: how can we produce more food with fewer resources? The New Delta represents one of the largest real-world attempts to answer that question. Yet the project also comes with enormous challenges. With an estimated cost approaching $10 billion, the New Delta depends on a vast water treatment and distribution network that may consume as much as 10 million kilowatt-hours of electricity every day. If successful, a region once defined by sand and rock could become a model for arid nations across the world. But if it fails, it may go down as one of the most expensive agricultural gambles in modern history. Do you think New Delta will be remembered as one of the greatest engineering achievements of the 21st century, or as a costly lesson written in the sands of the Sahara? In our next video, we will travel to Australia, where people are not struggling against the limits of survival, but instead trying to control millions of invasive animals that have grown beyond human control. California, by nearly every measure, is a true powerhouse. Yet it is also a state carrying a fatal weakness within itself. Nearly 39 million residents live in a place without water. The paradox is that although nearly half of the state's total area is covered by desert and arid land, California is not only home to two massive coastal urban regions, but also the agricultural heart of the United States. Nearly all of America's leafy greens during winter come from Imperial Valley. Meanwhile, Central Valley produces nearly 40% of the nation's fruits and nuts, even though the region accounts for only around 1% of total U.S. farmland. By natural logic, this should have been one of the most difficult places in the country to develop agriculture. So, how did California achieve it? Part of the answer lies in advantages few places possess. California is almost a perfect natural blueprint, with a rare Mediterranean climate and more than 300 sunny days each year. In addition, more than 700 miles of the California Aqueduct, along with systems such as the Los Angeles Aqueduct, the Colorado River Aqueduct, vast irrigation networks, and groundwater extraction, have pulled water from the north, from melting mountain snow, and from distant rivers to feed dry valleys. California did not wait for nature to allow it. It forced nature to serve it. But every system built to defeat nature comes at a cost. California's agricultural achievement is both a victory over natural limits and a growing contradiction. Agriculture now consumes about 80% of the water used by humans in the state, while the population continues to rise and the climate grows hotter. That is why the greatest debate in California is not whether agriculture has succeeded, but rather this question: how to divide a finite water supply among farming, cities, and the future of the state itself. Because despite every pressure, the fields here have never stopped operating. And to understand why that miracle still exists, we must begin with the very harvests that continue each day to resist the limits of this land. The journey of California's agricultural machine can begin with one of the most demanding yet most beloved fruits in the world: strawberries. Strawberries are extremely delicate and can be bruised after only a few minor impacts, so harvesting is almost a brutal race against time. As the sun rises, thousands of workers are already bent over the planting rows, hand-picking only the berries that have reached perfect ripeness. An experienced worker can harvest hundreds of pounds per day, earning around $18 per hour or more during peak season. With strawberries, the moment they are picked is the moment the race begins. While many states have only a short strawberry season lasting around 4 to 8 weeks, California can maintain harvests for 8 to 10 months, even nearly year-round in some coastal regions, thanks to its mild climate and overlapping production zones. This is an advantage no competitor can replicate. The state currently produces around 90% of total U.S. strawberry output, with more than 1 billion pounds per year, far ahead of every other state such as Florida or North Carolina. The commercial value alone often exceeds $2 billion annually, making strawberries one of the highest value fruits in the state. Those trays of strawberries are then moved immediately into cooling facilities, sorted, packed, and loaded onto refrigerated trucks within hours to reach distribution centers across the United States. From supermarkets, dessert chains, and restaurants to yogurt brands, ice cream, smoothies, jam, pastries, and countless processed food lines, all depend on the continuous daily flow of fresh California strawberries. From an ordinary fruit in the American market, avocado has exploded into a symbol of brunch culture, avocado toast, guacamole, and a billion-dollar healthy living trend. Originating from the ancient lands of Chile and Peru, avocados later surged strongly in Mexico before entering the modern North American market. Today, California is the largest avocado-producing center in the United States, dominating around 90% of domestic output, with roughly 300 million pounds per year, depending on the season. Unlike strawberries that can be replanted quickly, avocado is a perennial tree that requires 3 to 5 years before reaching commercial yields and demands a stable water supply through every season. On average, each avocado requires about 320 liters of water to fully develop, a figure that has sparked major controversy in California during prolonged drought periods. During the harvest season from around February to September, workers must use clippers to cut each fruit by hand, gently place it into bags worn on the chest, then transfer it into large bins to avoid bruising the skin. From there, avocados are sent to processing facilities to be washed, sorted by size, controlled for even ripening, and packed before being loaded onto refrigerated trucks headed to supermarkets across the United States. In a state facing both water shortages and mounting consumer waste, even avocado byproducts are being turned into new resources. California generates more than 40 million tons of waste each year, with single-use plastics posing a major challenge to recycling systems and coastal environments. As a result, avocado skins and pits after processing are being utilized at around 30% to produce bio-oil, cosmetics, compost, and many environmentally friendly biomaterials. Would you be willing to pay 1.5 to 3 times more for these green products instead of conventional plastics? No crop represents California's prosperity and the water cost behind it more than the most hated nut in America: almonds. California is currently the largest almond center in the world, supplying around 80% of global output and nearly 100% of U.S. production for many years. Each year, the state produces more than 2 to 3 billion pounds of almonds, with export value reaching billions of dollars. California's almond orchards are not sustained by rain. They are sustained by water carried from hundreds of miles away, flowing through drip irrigation lines with almost absolute precision. Every late winter and early spring, a massive biological migration takes place. More than 2 million honeybee hives from across the United States are transported by truck to California to pollinate millions of acres of almond orchards blooming at the same time, one of the largest pollination operations on the planet. During harvest season, usually lasting from around August to October, giant tree shaker machines clamp tightly onto the trunks and shake them violently for a few seconds so that all almonds fall onto the ground, which has been cleaned beforehand. After that, sweeper machines gather the nuts into long rows between the orchards, and pickup machines vacuum the entire layer of still-shelled almonds into storage compartments. From there, the almonds are sent to factories to remove the outer hull, dry them, sort them by size, inspect quality, and package them before being exported worldwide. But no crop has been criticized more than almonds. On average, producing just one almond may require around 3 to 4 liters of water. The problem is that almonds are a perennial crop. Once planted as orchards, farmers are forced to keep irrigating year after year to protect an investment that spans decades. With almonds, California cannot simply turn back. Its very success has locked in the choices of the future. If almonds represent wealth and controversy, then tomatoes represent California's pure industrial power. During the harvest season from around July to October, giant tomato harvester machines move straight into the fields, cut entire plants from the ground, then shake the fruit loose inside the mechanical system. Leaves, soil, and debris are removed while conveyor belts continuously dump tons of tomatoes into trucks driving alongside. In a short period of time, entire fields can be harvested cleanly, helping generate more than 10 to 12 million tons of processing tomatoes each year. But harvesting is only the first step. Because tomatoes ripen quickly and lose quality easily, trucks often drive directly from the fields to nearby factories. From ketchup in fast food chains, sauce on frozen pizzas, pasta sauce in supermarkets, to canned soup and convenience foods, millions of Americans consume California tomatoes every day without ever seeing where they began. California is currently the largest processing tomato center in the United States, often supplying around 90% of the nation's processed tomato volume. That is the paradox of California tomatoes. Less romantic than the image of traditional farms, yet one of the most efficient agricultural machines ever built. America rarely notices lettuce until store shelves suddenly go empty. From burgers, sandwiches, and salad bowls to fast food chains and convenience stores, lettuce appears almost everywhere. With its delicate and temperamental nature, lettuce is also one of the agricultural products that demands the highest speed. During harvest season, which takes place nearly year-round thanks to overlapping growing regions, cutting machines or manual labor crews move continuously through the fields, cutting lettuce, packing cartons, and transferring them immediately into cooling systems within a short time. Because lettuce contains a high amount of water and loses crispness easily, every hour of delay causes quality to decline rapidly. Those cartons of lettuce are then loaded onto refrigerated trucks, leaving the fields for distribution centers, supermarkets, and restaurants across the United States. From the moment it is cut from the root to the moment it appears in a burger or salad bowl, time is always the deciding factor. Regions such as Salinas Valley, Monterey County, and Imperial Valley create an overlapping seasonal production chain, supplying around 6 to 8 billion pounds of lettuce each year, and helping this vegetable remain available almost year-round across the American market. However, because it is consumed fresh and almost never cooked, lettuce also carries higher food safety risks than many other agricultural products. When lettuce faces a problem, the entire United States suddenly realizes how dependent it is on it. That is what makes California lettuce unique. Little glamour, little attention, yet operating like a gigantic logistics machine. For decades, onion harvesting by hand, usually taking place from August to October, demanded hundreds of workers to pull, gather, and transport each bulb out of the field. The arrival of the first rear-mounted onion harvesters changed that. With a simple digging blade and a vibrating screen, they could lift the bulbs from the soil, remove excess dirt, and lay them neatly in rows. These machines are still common in the Netherlands, China, and India, where many farms remain small to medium in scale. However, the major limitation was that onions remained on the ground, requiring manual collection. To solve this, The next generation, harvesters with high elevators, was developed. They not only lifted and cleaned the onions more effectively, but also transferred them directly into trailers or trucks driving alongside. This continuous flow saved enormous amounts of labor and time, and such machines are widely used today in Western Europe, the United States, and Canada, where fields can stretch across tens or even hundreds of hectares. At an even larger scale, multifunctional trailed harvesters from companies like DeWolf and Simon pushed efficiency further. These machines added advanced leaf cutting and soil separating systems, delivering cleaner onions straight from the field and reducing the workload for post-harvest handling. The pinnacle of this evolution is the self-propelled onion harvester. Operating independently without a tractor, these giants feature comfortable operator cabins, GPS navigation, and precision sensors. Modern models such as the DeWolf Enduro or Grimm SE series can process 50 to 70 tons of onions per hour, replacing the labor of hundreds of workers. Each year, the world produces over 100 million tons of onions, with India alone consuming more than 20% of global output. Altogether, the onion industry generates over $40 billion US annually, a striking demonstration of its immense economic value and the role of mechanized harvesting in sustaining this demand. Gone are the familiar images of farmers holding handheld sprayers. Today, it is the autonomous sprayers that are redefining the future of modern agriculture. Across vast green fields, the John Deere See & Spray Ultimate extends its massive spray booms, gliding with centimeter-level precision. Equipped with advanced cameras, sensors, and artificial intelligence, it can detect individual weeds among thousands of crops, targeting only the areas that require treatment and reducing the use of pesticides by up to 90%. Its vision system is so advanced that it can scan up to 4,000 frames per second while operating at speeds of up to 15 miles per hour, ensuring unparalleled accuracy even across massive fields. Beyond cutting costs and protecting the environment, this breakthrough elevates farming into a high-tech industry where robots and AI replace backbreaking labor, delivering a level of efficiency never before seen in the history of cultivation. So, are you ready to invest $500,000 to $700,000 to own this cutting-edge machine? Seen from above, the rice field in spring in Japan looks like a giant canvas, where the machine quietly draws perfectly straight lines across the watery surface. The modern Yanmar rice transplanter eliminates the back-breaking labor of manual planting by automatically inserting young seedlings into the field, completely replacing traditional hand planting methods that once consumed so much time and effort. What makes this machine remarkable is its integration with a GPS satellite navigation system, allowing operation with centimeter-level precision. As a result, every row of rice is planted in flawless alignment, evenly spaced, and at consistent depth, minimizing both gaps and overlaps. In practice, a single Yanmar rice transplanter can cover 0.5 to 1 hectare per hour, up to 8 to 10 times faster than manual labor. During operation, the farmer only needs to steer and reload seedling trays at the back, while all movement, adjustments, and planting are fully automated. The synergy of precise engineering and smart satellite technology not only saves time and reduces labor costs, but also boosts productivity and crop quality, marking a new milestone in the modernization of agriculture. After 4 to 5 months of waiting for the rice to ripen, farmers in Japan usually rely on small Kubota combine harvesters. These compact machines are light, agile, and perfectly suited to the narrow plots and fragmented terrain of traditional Asian farming. But in the United States and Europe, the scale has been raised to an entirely new level. On vast open fields, giants like John Deere, Case IH, New Holland, and Claas operate with cutter bars stretching dozens of meters. Their mechanism works like a massive harvest line. The cutter slices the stalks, the threshing drum separates the grains, the fan and sieve system cleans away husks and straw, and the kernels are unloaded through an auger into a trailer moving alongside. Meanwhile, the straw is chopped and spread evenly back onto the field. This extraordinary efficiency, 40 to 50 tons per hour, harvesting hundreds of hectares in just a few days, is what has transformed the United States into a true agricultural superpower, far beyond the smaller machines of Asia. Hundreds of giant white snakes, stretched endlessly across the fields, are in fact grain baggers, modern machines that revolutionize grain storage in 21st century farming. After harvest, corn, wheat, or soybeans are poured into the hopper, where a powerful auger compacts the kernels and pushes them deep into massive polyethylene bags. These bags can stretch 60 to 75 meters long and hold up to 250 tons of grain, the equivalent of a full-size silo right there in the field. Together, these three crops account for more than 2.3 billion tons produced globally each year, making grain baggers an indispensable solution for handling such vast quantities. No longer forced into a post-harvest rush, farmers in the US, Canada, and Argentina now turn their fields into sprawling mobile warehouses, a striking symbol of modern agricultural innovation. If this machine had existed 70 years ago, European farmers would not have had to spend months digging drainage ditches by hand. Today, in fields with heavy clay soils or areas prone to flooding, poor drainage can easily wipe out entire crops. To solve this, subsurface drainage machines like this are used. At their core is a massive plow blade mounted on a tracked chassis, capable of cutting 0.8 to 1.5 meters deep into the ground. As the machine advances, it simultaneously opens the soil and lays perforated PVC or PE pipes underground. Behind the machine, a large coil of pipe is gradually fed into the trench, which is then immediately backfilled, creating a hidden network of underground drains across the field. This system removes excess water after heavy rains while maintaining balanced soil moisture for crops. High up in the rolling hills of Europe, where steep and rugged terrain makes grass cutting with heavy machinery almost impossible, these compact drum mowers have become the perfect solution. Equipped with two cylindrical drums fitted with dozens of sharp blades, the machine spins at high speed to neatly slice through thick layers of grass, leaving behind evenly cut swaths. In just 1 hour of operation, a single unit can process 4,000 to 5,000 square meters of grass, a performance far beyond that of traditional handheld mowers. When started, the rotating drums generate strong friction combined with the cutting blades, creating a forward-driving force that allows the mower to move on its own without being pushed by the operator. Weighing only about 100 kilograms, its lightweight frame and flexible wheels make it easy to work even on steep slopes or terraced fields. Thanks to its mobility and impressive efficiency, this machine has become an indispensable workhorse for dairy, beef, and sheep farms, with a price of about $6,500. If you think the machine before your eyes looks like a giant clay-shaping press, you are mistaken. The peat harvester is a specialized machine designed to cut, crush, and collect peat, a vital resource used in energy production, organic fertilizers, and soil improvement. A massive cutting disc at the front digs deep into the peat layer, while the mechanical system grinds and compresses it into uniform cylindrical blocks. These blocks are then laid out in long rows across the field to dry naturally under the sun before being collected and transported. With its sturdy build and oversized tires, the tractor can freely frolic on soft, waterlogged ground without worrying about getting stuck, as if it were taking a mud bath. A modern peat harvester is capable of processing tens of tons of peat each day, leaving behind endless rows of neatly formed blocks stretching across the landscape. Across vast hazelnut orchards, the harvest usually takes place from late August to early October, with Turkey leading global production at around 800,000 tons per year, followed by Italy and the United States. Harvesting each tiny hazelnut by hand from the ground is extremely time and labor-intensive, which is why modern hazelnut harvesters like this have become the ideal solution. At the front, the machine is equipped with rotating sweep discs that continuously gather hazelnuts scattered among dry leaves and grass. Immediately after, a powerful suction system transfers everything into the processing chamber, where leaves, twigs, and soil are separated out, leaving only clean hazelnuts. Each day, a single machine can harvest several tons of nuts, all collected into the large rear container, ready to be transported to processing facilities. From June to August each year, across the vast fields of the United States, cucumbers destined for pickles are harvested by specialized machines. Unlike onion harvesters that dig bulbs out of the soil, these machines are designed specifically to separate the fruit from the plant while keeping each cucumber intact. Using a system of clamps and conveyors, the machine gently lifts the vines, detaches the ripe cucumbers from stems and leaves, and passes them through a cleaning unit that removes soil and debris. Thousands of fresh green cucumbers are then transferred into large storage bins before being offloaded into trailers moving alongside. In just 1 hour, a single harvester can handle tens of tons of cucumbers, replacing the work of hundreds of manual laborers. Today, although China is by far the world's leading producer of cucumbers, accounting for more than 70 million tons each year, the United States stands out with its advanced harvesting technology, especially for cucumbers grown specifically for pickles. From the fields, these cucumbers quickly make their way to processing plants, soon becoming familiar pickle jars found on dinner tables under brands such as Mount Olive, Vlasic, and Clausen. Standing out as one of the most iconic symbols of autumn, the pumpkin becomes the opening character in our harvest journey. Across the United States, with Illinois holding the title of pumpkin capital, vast golden fields come into season from late September to November, just in time for the excitement of Halloween. Fresh pumpkin harvesters use sharp blades to cut through thick stems, while mechanical arms lift the massive pumpkins from the ground and place them onto conveyor belts. Rotating rollers and brushes remove excess soil before the plump pumpkins are neatly deposited into storage bins at the rear. With a continuous rhythm, thousands of pumpkins are gathered within just a few hours. Unlike fresh pumpkin harvesters, pumpkin seed harvesters have a more specialized design. These machines crush and separate the entire fruit directly in the field, sorting out the seeds through screening systems, while the rind and flesh are discharged back onto the soil as organic fertilizer. By combining these two technologies, American farmers not only meet the enormous demand for fresh pumpkins in holiday markets and food production, but also maximize economic value from the seeds, driving annual yields to more than 680,000 metric tons. Farewell to the diligent farmers across the fields of Illinois. Now let us journey to Wisconsin and Massachusetts, where every September, farmers harvest their rewards, glistening like crimson jewels upon the water. Unlike pumpkins, cranberries are harvested using a unique method known as wet harvesting. When the season arrives, farmers flood the bogs with water, then deploy special machines called water reels or egg beaters to stir the vines and loosen the berries. Thanks to tiny air pockets inside, cranberries rise and float, creating a spectacular sight. Thousands of bright red berries drifting like a floating carpet across the water's surface. Next comes the conveyor harvester, a modern harvesting machine that drives directly through the flooded bog. At the front, steel tines sweep the floating berries into the intake, while rotating conveyors lift them up, drain the water, and deposit them straight into boats or bins along the bog's edge. This method accelerates collection, reduces the need for manual boom corralling, and minimizes damage, making it ideal for large-scale cranberry farms in the US and Canada. Much like the bison roaming the Great Plains, the sight of flooded bogs shimmering with cranberries has become an enduring symbol of North America, a living image that captures both its natural abundance and cultural identity. Another approach that is becoming increasingly widespread is the conveyor harvester, which demands an investment of $250,000 to $400,000, but delivers far greater efficiency. At the front, steel tines sweep the floating berries toward the intake, where rotating conveyors lift them up, drain away the excess water, and deposit them directly into waiting boats or bins along the bog's edge. Each year, harvesting 700,000 tons of cranberries can require millions of liters of water, but Ocean Spray, the largest farmer-owned cooperative in the United States, emphasizes that much of this water is reused throughout the season, while accounting for nearly 70% of the nation's production. Nearly 90% of the products we use every day contain sugar, and much of that sweetness begins in the sun-drenched sugarcane fields of Brazil, where farmers harvest around 650 million tons of cane each year. During the 2025 season, Brazilian farmers must race against time to cut and process sugarcane before it is sent for crushing and export. Before the 2000s, both American and Brazilian farmers commonly burned sugarcane fields before harvest, especially in São Paulo state, which produces more than half of Brazil's output. It might sound unusual, but the purpose was to remove dry leaves and unnecessary tops. This left the stalks cleaner, reduced excess debris such as fallen leaves, organic matter, and insects, and made manual cutting faster and more efficient. However, because of the enormous amount of smoke and harmful emissions it generated, Brazil has implemented a program to almost completely eliminate pre-harvest burning, shifting instead to mechanized green cane harvesting. But in the United States, especially in Florida, burning sugarcane before harvest is still common. If you were there, how would you explain the reason behind it? Against this backdrop, harvesting fresh, unburned sugarcane with modern machinery is increasingly being promoted and has quickly become the dominant path forward. Specialized harvesters cut the cane close to the ground while simultaneously stripping leaves and tops right in the field. The stalks are lifted onto trucks by conveyor belts and transported straight to the mills on the same day. If the harvest is delayed, the sugar content in the cane drops rapidly, making it prone to mold and pests, which reduces its market value. That is why Brazilian farmers always strive to deliver the cane to the mills within 24 hours to ensure the best quality.